Hey guys, welcome to Bright Brains. Today we are going to discuss about the theory of relativity. This theory contains two interrelated theories by Sir Albert Einstein, which was proposed in year 1905. They are special relativity and general relativity. Now let's learn about these both theories deeply. Special relativity. Special relativity applies to all physical phenomena in the absence of gravity. Means, in the special relativity, all the physical concepts like force, work, energy, power, tension, vector quantities, and many concepts, but when these are applied when there is no gravitational force acting on these concepts. Now, coming towards the general relativity. General relativity explains the laws of gravitation and its relation to the another forces of nature. As we know that gravitation is a very vast concept of physics and it was very important to study its nature with other forces in the atmosphere or in the universe. So it's very important to understand that in the general relativity all the gravitational laws are different than that were proposed by Sir Isaac Newton. Okay? So now you would ask that why is this theory of relativity so important? So it's very important as the theory of relativity has improved the modern physics a lot. With this, astrophysicists predict many extraordinary concepts like neutron stars, black holes, wormholes, and gravitational waves. Now let's come on the topic E is equal to mc square. This special relativity equation was given by Sir Albert Einstein to express that mass and energy are the same physical quantities and can be changed into each other. Now let's see its proof. The famous mass energy equivalence relation of Sir Albert Einstein, that is nothing but E is equal to mc square or m is equal to E upon c square. Yeah, so let's learn about this. Now how to prove that? First I will give you an example. So see that, let's consider this is a road and this is an object of mass m. So when I will apply some amount of force, this object of mass m will move with some velocity ahead. So let's write that first. So first we need to consider an object. This is an object with mass m which is moving with a velocity v. So as you know that this object will have some momentum. So what is the formula for momentum? Yeah, it's P is equal to mv. Momentum is equal to mass into velocity. Yeah, this is vector sign on that. Yes. Now what you have to do? You have to just apply the second law of motion, that is linear momentum upon time, which will give you force. So now we will apply the second law of motion, that is F is equal to dt, that is linear momentum upon dt. Yeah. Now coming towards again dp, that is linear momentum. Now we know the value of p as we have taken it ahead up. So now let's put that m into v, that is mass into velocity, here in this equation. So let's put it. So F is equal to d by mv upon dt. Yeah. So after this, what you need to do? You need to differentiate the things. So I will first prove you one concept, that in the modern mechanics, both mass and velocity are variables. But in the Newtonian mechanics, only velocity is a variable and mass is a constant. Okay. So according to that, we will take the modern mechanics so we can differentiate both of them. So let's differentiate them. F is equal to, what will come here? First we will take m ahead and differentiate v, that is velocity. So first take m, my dv upon dt, addition sign and its multiplication here. So during differentiation, if there is a multiplication there, so you need to add the positive sign. Okay. So now let's take v by dm upon dt. Yeah. Now let's mark this equation as 1. Okay. Yeah. Now after this marking equation this one, now again come to this object. Okay. Now when this object will move, there will be some amount of work done to move this object. So we will now calculate the work done by force. So let's write that. Therefore, work done by force. Okay. So what we will write, that is we will calculate the work for a very small distance. That's why we are writing d. Okay. dw is equal to F force by displacement ds. Okay. So from here, what you understand? Now again come to the mass. Okay, mass of the object. Now what will happen here? when this object will move, there will be some amount of kinetic energy produced in this object and it will be stored. Okay, so now as we have learned that the formula of work and kinetic energy is same, so let's take kinetic energy there. So dk is equal to force into displacement. Yeah, now nothing you have to do, you have to just put the value of force from the first equation that we have marked there, and let's put that. Okay, so let me put that for you. That is dk is equal to, now what is F? In bracket we will take that F is equal to dv upon dt plus v by dm upon dt into ds. Yeah, displacement. So now coming ahead, what will happen is that now what you have to do, you have to multiply this displacement into this whole equation. Okay, so let's do that. So here dk is equal to, if here it will come then m by ds upon dt by dv. Okay, and again the addition sign there, and again v by dm upon dt. Yeah, sorry, here s will come of displacement into dm. Yeah, now it's right. Okay, so what is this? ds upon dt. I will simplify that. It's displacement upon time. So displacement upon time, as you all know, it's velocity. So let's take their velocity. So now dk is equal to m by v, that is velocity, into dv. Yeah. Now here we will add addition sign. Now again here displacement upon time. So again we will take v by dm. Yeah. Now let's simplify these things. dk is equal to mv, let's remove the multiplication sign between them, here v square by dm. Okay, so let's mark this equation as equation number 2. Okay, so now ahead, as you all know, Albert Einstein also gave a famous equation, that is m is equal to calculate the mass which is increasing while while the object is in motion. Yeah, so for that, what is the formula? Let me write it in the bracket. It's m is equal to, mass is equal to m naught, rest mass of the object, under root 1 minus velocity square of the object, and c square, that is velocity of light in vacuum. Okay, so now to simplify the equation, what we will do, we will square both the sides. So after squaring both the sides, what will come? It will come as like this: m square is equal to m naught square upon, here root sign will come out, mv square upon c square. Now we can easily solve this by cross multiplying. Okay, so let's take this below part up to multiply with m square. So what will come here? Here it will come as m square dot c square first, then minus sign will come because sign will change here, then m square dot v square, yeah, is equal to m naught square dot, okay, we will remove this dot, we will directly multiply it, it's c square. Okay, now nothing you have to do, you have to just differentiate the things. Okay, but I will first clear the concepts. Here you can only differentiate mass and velocity, but you can't differentiate, that is rest mass and velocity of light in vacuum, because these both quantities are constant, and as if you differentiate the constant quantities, it will come as 0. So we will take them as 0. But mass and velocity, as first only I have told you that they are variable quantities, so we can differentiate it very well. So let's differentiate now the things. Okay, so here 2m will come, 2m by dm, and here it's c square, so c square we will put here, minus again the sign will come, again there's m there, so 2m by d, okay, again there m will come, and by v square it will come this time. Okay, and now we will differentiate v, minus v square will come there, no, we will not take v square, it's a not square, it will come dv by 2v by dv by m square. Yeah, it will come like that. Okay, so now what will happen? So let's now see, here it will come 0, as this quantity is constant. In differentiation, constant quantity is converted into 0. Yeah, now here we can cut short some things. So let's see that here 2m will come, 2m gone to n, here again 2 will go with m. Okay, So now nothing is there to cut. Okay, so let's write final answer. That is c square we will take first by dm. Now we'll transfer these things to there because that's 0, and here calculation will be also good because here positive sign will come. Yeah, so let's transfer the things. Here I will transfer there. Okay, so let me transfer here. Okay, it will come mv dv. You can understand, no, here it was v square, so I have taken v ahead and m also ahead, so mv dv will come there, plus positive sign will come as here it's transferred here. So now ahead we can take it as v square because both the v's are remaining here, and here one m is remaining. Okay, so dm. Yeah, mark this as equation number 3. And now see that the equation number 2 and equation number 3 are same. So because of that, what will happen? Now the kinetic energy is equal to the rest mass of the increasing mass of the object. So now let's write them as like this. dk is equal to what we can take that dk is equal to, yeah, c square by dm. Yeah. Now we have to remove this d from this equation to make the equation more reliable for solving. Okay, so let's remove that dk there. So what we can do, let me write it again here. dk is equal to c square by dm. Yeah. So now what we will do to remove the differentiation, we need to do integration. So let's do integration. This is the sign of integration. Yeah. So now you have to give some limits to it because there may be some limits for the motion. Okay. There will be an initial starting point and there will be a ending point of the motion. So you need to add some limits here. So let's consider some limits. When the object was at rest, its mass may be m naught, and for moving it increased with m. Let's consider like that. Okay. And here the kinetic energy when it was at rest, it will be 0, and moving at some constant, it will be k. Yeah. Now it's reliable to solve. Now how we will solve it? We will just now solve it completely. K is equal to c square. Here directly k came. How it came? If you will solve fully, then you can understand. Okay, how it came here. First k minus 0, and k minus 0 is nothing but k. Okay, now d will remove. D will be removed. Now let's take m there. M by m naught by m. Okay, yes. Now let's again do the calculations there. C square by m by it's not will m. It's not come as m. It will come as m minus m naught. Yeah, it will come like that. Okay. So now from here, what we understand? From here we can take out the rest mass energy of the object, and how it will be taken out? It will be like what is the mass of the object as that is m naught, and we will multiply it with c square. Okay, so let's take out the rest mass energy. Rest mass energy, yeah. So what is the rest mass energy? Here it will come as is equal to m naught by c square. Yeah, here it will come as m naught by c square. Now all the terms are here with us. That's mass is there in this equation. Here it's velocity of light in vacuum. Now just one thing is missing, that is energy. So let's take out energy. So now total energy is equal to k plus rest mass energy. I will write it in short form RME. Okay, you can understand. Okay, so now what will come here? Therefore E is equal to k is equal to c square by m minus m naught, yeah, plus m naught by c square. Okay, so now let's solve it fully. Now here what will come? Sorry, let me draw this first. mc square minus m naught c square plus m naught c square. So what will happen here? It will be cancelled. M naught c square minus m naught c square. So therefore what will come here? It will be E is equal to mc square, or m is equal to E upon c square. Okay, so why this formula is used? Let me explain it. It is used to calculate the mass of the object. Yeah, to calculate the increased mass of the object. Whenever it said in this equation that whenever you will apply some amount of energy, if I will apply some amount of energy to this object, and it will start moving. so its mass will increase, and that time to calculate its mass, to calculate its increased mass, we need to use this formula. So this was the mass energy equivalence relation of Sir Einstein, and I have proved it for you. Okay, so thank you and keep watching Bright Brains.